Hi, I'm Shrikant from NC State University. In this presentation, we will discuss about the disconnect between practitioner belief and empirical evidence. The longer a bug remains in the system, the exponentially more costly it becomes to fix. Lessons learned from a few past projects are general to all future projects. Many go-to statements in source code induce more defects. Although belief X, Y, and Z seem intuitive, recently researchers did not find any significant support for them. Since it is not possible to cover all software engineering beliefs, we focused on software quality, specifically defect prediction beliefs. Defect prediction is basically to emphasize software quality assurance activities on modules, changes, or code that are likely to get defect prone in the near future. Hence, it is important to revisit prevalent beliefs. We chose 10 defect prediction beliefs in a qualitative study by Van and others in TSE 2018. The beliefs B1 to B10 are sorted by practitioners' agreement, meaning belief 1 is more trusted by practitioners than belief 10. Software engineering researchers in the past have acknowledged such disconnects between practitioner beliefs and empirical evidence. More recently, in ICSI 2016, Devenbo others shown such discrepancies exist even within the same organization. To answer that central question of what disconnects beliefs and empirical evidence, we broadly ask two questions. What beliefs are strongly supported in the data in the first place? And does the same support exist everywhere? Everywhere in the sense across all projects or among all releases, or do these beliefs fluctuate over time? To answer those research questions, we look for support of those beliefs in 37 GitHub projects. We use correlation between the belief metric and post-release defects to assess the strength of each belief. Say a project with R number of releases, and we want to assess the strength of a belief in release 6. So to do that, we capture a belief metric in the pre-release period, that is on release 6, and correlate it with post-release defects. Let me explain that with an example. Let's take belief 2. Files changed by more developers are more buggy. So in the pre-release period, and say release 6 of a project, foo.java, bar.java, and scott.java, 3 files have been changed by 3, 5, and 10 developers. And correspondingly, in the post-release period, assume the number of defects reported are 1, 4, and 7 on the same files, then such a result would support this belief, because when we correlate between the numbers 3, 5, and 10 with 1, 4, and 7, we get a very high correlation. Similarly, we assess the remaining 9 beliefs, that is, belief metric captured in the pre-release period correlated with post-release defects. And the results are shown as follows. Surprisingly, belief B10, which is only 30% agreement with practitioners, shows strong support similar to that of B5, whereas more popular beliefs B1, B4 shows weak support in our data. Now that we've seen large commits and ownership-based beliefs have strong support, we want to check whether all the beliefs are true all the time or the evidence is shown everywhere. Only 24% of the project showed support for all the 10 beliefs. What it means is that if a practitioner has some belief and they move on to a different project, probably the same effect may not hold true. The sporadicity of evidence among projects extends to even within projects, that is, among releases. For instance, belief B4 exhibits weak support in large releases as compared to smaller releases. In other words, what we did is we clustered project releases into three groups. Small releases where few number of files have changed, large release where many files have changed. So that such a support even varies for different size of a release. In the beginning of a project, if a practitioner have a belief that helps them to predict some defects, that particular belief may not yield the same effect after multiple releases over time. In other words, what we are trying to say in this chart is that belief support tend to decay most of the time than growing. Only 2 of 10 beliefs we assessed were strongly supported in the data among prevalent mostly among most releases as well as projects. The sporadicity of support prevalence and factors like project maturity and release size that explored the sporadicity answers the central question, which is what disconnects practitioner beliefs and empirical evidence. So, our suggestion for practitioners is that do not assume that all the effects all times and monitor them to adjust their software quality assurance activities and depending upon what works for their organization they should set policies and bet on only strong effects.